So, these questions are made by me somewhere in this document. So, yeah, you don't have to worry about anything, but yeah. So, what are the point of these questions is that we're going to go into what the purpose of each question is and the solutions, I guess. But um, the first question over here, the number one, I can point to over here. I will do this for now because otherwise you can't see my finger without me pressing it. So what is the sig fig of 3.25? Those are just two digits, 3.5, so that is two digits. So we can easily say that's two sig figs. Over here is more difficult. As you can see, how many sig figs are in this, but this is an error problem. So it doesn't matter about this portion. It matters about this portion. So that's two. Two sig figs over here says two is A. Why is this all A? I don't know. I think I chose my questions wrong. That's a big. That's a stupid question there. So there's a few ways to solve this one. I just like to go with convention rules, which just states for multiplying, you do 4 plus or minus. Oh, this is awful. So I go with convention, which is 4 plus or minus. There's actually a way to solve it by saying x plus x parentheses y plus parentheses x. I'll show that off here later. But I like to do it like this, parentheses that. Oh, this is going to be a horrible percentage. I just um, there's also another way with partial derivatives, but I'll show that off too, actually. Why not? So, oh my god. 5 plus 1 minus 4 divided by 5. These are percentages, as you can see. These are percentages. Yeah, and then you add up the percentages. That's what happens, and then you redistribute it again. But I just realized that, oh yeah, and then there's actually another way to do it over here. I'll explain that way too. Okay, so these two ways I'll explain here. So this way is assuming that we do not y. I think I'll choose z plus y x, and we do a partial derivative over here to x and partial derivative of y and partial derivative of z, I believe. And you multiply by the error over here and then square root it. I'll, and then plus or that's the plus or minus and add it to the. Actually, I'll do this way and then show it off. It's much easier to show it off. Um, and I'll show it this way too. It's this way is actually how you get the percentage way and the reasoning of the percentage way. But yeah, so yeah, I need that to reason this out. So um, because multiplying and dividing is the hardest part, and you can also do it for division over here. So you get xy, but let's do the partial derivative way because that is actually the most standard way you're going to probably do it. The standard partial derivative of z plus xy equals 1 because of this. Most likely you're not going to learn this in 4a or 4b. Most likely, actually, because you're going to probably learn it in 2BL instead, the lab portion of that, um, because it's more useful in lab. Although in 4A at least, which is physics major, they actually do teach a little bit of that apparently in the beginning, but they cut off later. And for 2A, they don't even do this. So, and then this equals, let's see, x, so it's y, and this equals x over here. What we do after that is say the error point over here. So the error is 3, 1, 1, 3, 4. So 1, 3, 4, and then do this, and then square plus plus. We multiply this by our corresponding. So z first, so z is apparently 1, so that's square root of 1 square. I forgot to write square here. Plus minus. Over here would be y because that's a partial derivative of x over here. So y is what's y again? 5. So that's 15 squared plus 4 x, which is 3, so it's 12 square. So if you get that, let's see if it makes any sense, because I think the error is too big now looking at it. I didn't, as I said, I made these questions, so the error might be awful. So the error is awful. It's apparently 19, which is goddamn. This is like fuck me, because because if you look at the addition over here, that's 2023 plus or minus 19. This is an awful question. I just realized this is a. I just realized how awful this question is. This is a joke question. This is a joke. Um, well, I made this, so I'm the joke apparently. So yeah, that's how you do it the more formal way to do if you have something like e to the x something, e to the x y makes more sense because you get an error of +3. If you have this kind of question, it makes more sense to do that, right? Or some fancy equation that you don't want to do. But uh, I want to do the standard way, not this way, because this way is awful and it's not going. It's good, but it's not going to be taught until 2BL, or purposefully not taught until because you didn't learn calculus yet. You're not supposed to know this until then, which I don't care because I'm a student. I can. I don't. It's not. It's not my. It's not my problem to say anything like this, right? So another thing over here is oh shit, I made a here. So over here, if you look at this, am I doing this right? I am doing this wrong. Okay, what did I do wrong again? I forget. So I forgot how to do this. Oh my god. This is something that I should know. It's xy plus, let me go xy. Oh yeah. X error prone by x. Error prone. Then plus y error prone by y. Um, and then plus the double errors. Okay, now we got it. Double errors here, one error here, one error here. So we divide everything by x, y, and you can see that equals. Wait, that's not right. I think I did something wrong, but let's just go do it. X divided by y, you see over here, plus y divided by x plus, oh, okay, I definitely did something wrong here. That's not supposed to happen. Man, I always make these mistakes. I have it in my notes somewhere, actually, probably. Yeah, get that out. Yeah, yeah, something like this wrong here. I'm pretty sure that's how you do it, but that's the reasoning. That's the same reasoning. I just did some bullshit wrong here. Yeah, okay, oh yeah, right. So the first thing to note is that this, if you multiply this error usually goes to 0 because the error in that is usually too small to care about. But because I made this question weird, that actually would matter, unfortunately, because it's such a high percentage. Ah, I did this wrong. Yeah, sorry. Yeah, the secret to this is actually I made a mistake. You actually want to get XY out of there and turn it into this format, actually. So, my God, come on, work for me. Oh my God, it's just not working. Let me, um, AB plus OB, you usually do this one. And, oh, something is wrong, actually. It's wrong. Oh, yeah, I definitely did something wrong. Okay, something's wrong with this equation entirely. Okay. I'm making a fumbling mistake here. Unfortunately, it's only 10 minutes, so I can actually keep on going. I don't want to restart this mistake. And so it should be something like 19 if I do this correctly. So AB plus A integral B plus B integral A plus integral B should be, yeah, this equals almost zero. Should almost equal zero usually. So yeah, this is what should have happened. And if you do it again, that's that's where the derivation goes. My God, I don't know where I made a mistake. I don't know, but um, if you look at that, then it turns out that this is what you get. Honestly, you don't need the rotation after because you're gonna use it a lot, and who the fuck cares about the rotation? Whatever, I don't care. So let's not do that ever again. Because that's painful for me because I got it wrong completely. As a student, I should know this by heart, but I don't. I fucked and I messed up. But the general sense of that stupid theorem that made me go crazy is that this is equal to 3 divided by 4 parentheses. I can do this. Just watch. That's a better idea. So 4 divided by 5, and I can just say 20 plus or minus the percentage add up. So 75% plus 80%. What the hell does no wonder the error is huge. It's uh oh my god. Okay. I know why it doesn't work. The error is 60, 80, and 60. So you cannot actually use this method. Because usually your error is 0.1 and your error is like something like small. So if what's happening is the double error I talked about over here um, is getting too big. Usually this 2 goes to 0. Right now it's going to a huge amount, so you can't actually use the percentage. I thought something was weird. Okay. Yeah, the error actually matters, unfortunately. Which is a big problem. Then you have to use a partial derivative on this one. So let's just change this entire question because I'll have to change that in my question bank to something like this. My God, that question was awful. This is why you try all your questions before you give them out. Oh, no, that's funny. So what you're supposed to do is get something like this. Uh, um, yeah, and then 5, and then that should equal some very small percentage that should be able to add up to each other. Yes, that equals 0.075 divided by 5 equals 0.08. Now we add those together. Oh my god. Which equals 0.155. I multiply by 100 to get the percentage if you want the percentage for some reason. But I don't want the percentage, so I can just say 20 multiplied by 0.155. So 20 multiplied by that number equals 3.1. Okay, I'm using calculator if you can't tell. So next thing is 3 plus 0.1 plus I forget 20 plus or minus 3.1. By the way, because errors can be only one digit, you have to get rid of the 0.1. Zeros, infinite zeros don't count. These zeros don't count. Um, I should point that out with a laser. These zeros don't count. So if there was a 0.1 over here, then you have to get rid of it. So that's where we are. Now we can say it's 23. Now we have to do the square root of 0.1 plus or minus square 3. This is no matter what the case is, you need to do this, I believe. For addition, I believe. Some people don't like doing that. I don't know why. That's plus or minus 3.00. So that is 23 points plus or minus 3. And that 00 cannot be in there because this is error and you have to keep it in this format. So that question was goddamn awful. No wonder it didn't make any sense to me. The error was way off and it was crazy. Fortunate for me, that means that that question was awful and shouldn't be given to anyone. So, noted. The error was too big. I didn't know that problem could occur. So, because, yeah, we're gonna see that a lot. Because these are homemade questions, so this is writing in physics. So in writing in physics or any science discipline, I'm just a student, so this is just awful. Anyway, in physics, we have a few things that we can't write. I, you, me, he, she is illegal because that's not scientific. But in modern day, actually, they're trying to change that a little bit. Uh, but that's neither here or there. We don't care about that right now. You need, and then, but why is this error over here? This error doesn't qualify for any of these weird instances. Well, it's because they use because in the first sentence. So it could be changed if this happened. The bubble gum. Let's just imagine I wrote bubble gum exploded. Imagine if I wrote exploded because that would work, and then the rest. This happens also not okay, but I did not. Uh, the question which is so awful. It's obviously C. I should change this question. Obviously C A. Sorry, it's obviously A. This question is awful. I need to change this shit. This is the most awful question I've ever made. Um, After that, okay, this one is a proof question. Um, but I just don't care about this proof. And okay, so honestly, this is for a shit. This is for a shit, which means physics major, or 2BL, 2BL. And then this is 2BL definitely, not even physics major. This one over here is none of them because this is writing, so this is another course in general. So this is 4A, which is majors. This is these are labs for 2ABL, and this is like for nothing. So it's just junk. Um, if you're not doing this, but yeah. So, okay, so this is definitely a 4A problem, which is a physics major problem. But I don't care. So I am just going to solve it out here and hope you get it because 2A doesn't care about this shit. But what's happening here is that we have a constant A, so which implies this thing. Uh, implies this thing, but initial and final are not initial and final. It's two random points. So we have to use zeros and ones if I ever used one here. I don't remember if I used one to describe the initial and final point of what we're talking about. Yeah. Initial and final points for the final initial over here. So I should use a red pen. Initial and final over here. Probably not. Never on the test because this is awful to do. Because I never seen a proof question on a test. So we get down here, we do this shit, and this over here. You can look at it. I don't really. I kind of wish I can do it individually. So maybe I should do it right now. How much time do I have left? It's 20 minutes long. So all right, so if I have time, I'll do that individually. But for now, I'm just gonna look at it. So why this one is obviously F equal ma, and why are they the same? Fuck, these questions are awful. Is this obviously? But what's the point of this? Well, I want to talk about F equal ma and how it relates to the first law. Obviously, we know that if objects not move at any rate, then therefore what will happen? Oh wait, this question is awful. Just what the fuck. Anyway, if the zero forces and m, this kind of, then there's no acceleration. So that kind of tells that if there's no outside movement, the object will go in the same velocity. But the first law, why would Newton write this when there's already the second law? The point of first law question is to say that there's a reference point. It's not we say it's the um, if there's no interaction, the particle will go on forever. The velocity, but the point is to find an inertia frame of reference. So like a world, and that will you can see a velocity of a star or a jet plane, whatever relation to the world. We can see the acceleration over here, and we can make double vectors over here like this to get different ratios plane. If the let's just say if a car is moving and you see this and you have to add those vectors up, that's kind of what we're doing over here with the first law. It's not only the object is not moving, it's just constant in motion. But for 2a, 2a, saying that the object is in motion is if there's no acceleration, then there's no, that thing is fine. But if an object is in space, it'll keep on moving, it's fine. But for a, you can't really say that because the point for a is to say the reference point. That's why Newton created it, because there's no point of the first law if that was the only reason, because the second law exists. So that's what I'm trying to say here. And that's goddamn mouthful. Next over here is a basic layout of a motion like this. The So it's the basic shoot diagram. You can look through it. I was gonna do another one here, but I'm not, because I realized it's gonna be a lot of time. But yeah, that's the basic second diagram of, yeah. And over here I want to say v1 equals 3 meters per second, v2 equal 5 meters per second. As you can see, if you're given two velocities and we're told that different meters like this, if you're going 10 meters here, sorry, that's not right. So 10 meters here, 10 meters A to B. And for 3 meters over here, this is 1D diagram. So 1D motion like this. And you get this part, you have a different velocity. You can use the fact of this relationship over here to get this, because there's no acceleration. The acceleration is constant here. We never talked about acceleration changing. So we can oh, there's no acceleration here, zero. So v initial vi, that's what I meant to say over here. I should have done something like this. Um, so there's no acceleration at all. It's just zero. It's not even constant. It's constant, but it's constant zeros. So we can figure out the distance of length over here and distance length over here related to this and get this formula. And we can plug in v1 to 3, which equals 1. I should change this to 7, which is 1 divided by 10, which equals 10. What was I looking for? What this is equal to actually? Time, 10 seconds. That wording could be better. Oh well, I should have said 1D motion or something. Anyway, over here, if you have a train, so if there's a train over here and you see it, it's basically saying if there's a oh wait, it's on an airplane. If a train is somehow on an airplane and you see it moving, you just add up two vectors. So none of these are the answers. I think it should have been equal. Error my part. Oh, the hell am I doing with my life? Yeah, you can solve this yourself. Here, do I have time for this? Let's go with this one first because that's obviously b. Because if you know the initial velocity, that includes the angle because velocity is not a scalar, so it is a vector which has a magnitude and direction. So, wait, that's wrong. Shit. That's wrong. Initial location and initial velocity is c. C is the answer. Sorry. And we need the starting point. We need the initial location. Uh, Honestly, this is me trying to get myself ready. Later on in the future, I might want. I need to teach this, and uh, I have experienced myself talking to a stranger. Which okay, this part is just I'll explain if we ever have a next part, and I'll keep this open if I want to redo any of these uh, concepts. Anyway, I'm a student, so I should basically I'm just doing this for fun, and if in the future I want to do this, you know, Peter's constant, I already tried it, so I know what to expect from my errors and what I should be doing next time. God damn it! This was the worst question I made so far. Okay, good to know that that question's goddamn ugly and disgusting. Uh, I should get rid of these. Okay, I know for next time. And yeah, these are questions I made, so I should probably change the ones I hate and just load because of how stupid they are. For example, this one, the one that I have an arrow on, big fat arrow. That's so dumb. Really, that's the dumbest mistake I made. But yeah, so I know that story minutes almost, so I'm gonna stop here probably. But before I stop, I should probably, because I'm just a student, I'm just trying it out. I should probably try this right now, which is basically is asking for components, which if you're in 4A or you won't be given in 2A, so just cancel that out, or other known as non physics major. I believe they won't even give the luxury of saying components. Um, so you're gonna have to figure out that f equals 2 pi f frequency, and that equals oh my god, my brain work for me, 2 pi t, I believe, and then you have to figure out that this a equal w air square r. You have to say, oh, you don't need even this shit. That's stupid. It's the square root equal w. That's the first thing you need to know. And you have to plug it into the sine of WT plus cosine of WT with a W over here to get this change into V. And then you just have to plug in all this with 10 seconds. So you just have to say sine. But you have to do something like that. That's what you have to do. Awful question. But necessary question because of how I say this. So I don't like how it's 10 seconds actually. Maybe I should change it to 5 seconds. And then this one is minusing these two. I mean, no, not minusing. You make them equal to each other. So let me just write it like this. And then find the t points here, which is basically the quadratic equation. I don't want to do it. You can do it yourself. And then you just plug it back into these and find the two locations that they meet. They should be the same, and then the four velocities that you need. One of them might be negative, which is fine. I was tricked by that, but negative time is totally okay in physics. It just means that it's before time equals 0.